Hi, we are grade 11, and our topic is a money laundering detection competition. Our members are Debbie, Kevin, Jerry, Dave, Brian, and Louis. And below are our outline. We will start from introduction, related work, pre-processing, model structure, experiments, and final summary. This part is our introduction. The top score is our bottom line. It's our we first submit we have 0.01, and last time our progress check in left bottom one we have 0.02, and during these weeks we have 72% growth, and which make us 0.038 score. And now we are on our related work. The first one is sampling, because like in intuition, the number of normal transaction far exceeds the number of money laundering ones. So we try oversampling, because under sampling we will lose some data size. But you can see in our picture, without oversampling we get 0.015, but with oversampling we just get 0.01. So with this result, because the result get worse, so finally we give us sampling method during the whole process after. And the second part is our parameter models versus non-parameter models. And parameter models, which means it's rule-based, so the parameters are all setting before we get training. But non-parameter models is we get the parameter from tuning the model. So there are three advantages of using non-parameter models. The first one is adaptability. The second one is flexibility. So with these two properties, we can find a more complex pattern with non-parameter models. So in short, we just choose non-parameter models to fine-tune our later models in our whole process. And as we have mentioned, this is our pre-processing. We define our data with categorical and numerical. So you can see there are 4 kinds of situations, and we use different kinds of methods to fill in those missing values, outlier, normalize, and transform data. And with the process, you can see these are the examples of our processing data in customer info, DP, and CDTX. As you can see, this is our model structure. We get the last 5 data in different data set. And especially like you can see in DP, we just get the last 3 days data. If there are not enough data here, we will use padding technique to deal with the missing value. And you can see that we concat different kind of embedding data to dense layer, and then we get our output. And why CCBA and CDTX is not included in this model, we will explain it later. And now this is our experiment. The first one is change the penalty weight, because the data is very imbalanced. So if we get 0 to 1, we just give a slight penalty like 0.5. But if the model gets 1 to 0, then we will give penalty in different multiplier, like in 52, 34, and 26. And as you can see in the picture, we get the much more great result in 34. So this is our last parameters in this weight function. And our second experiment is change the layer size. As you can see in dense layer, we change 6 to 3 and to 2. As you can see, the 3 and the layer is the best result in this model. And lastly, we change the data set that concat in this model. So as you can see, 0 means customer info, 1 means DP, 2 means CCBA, 3 is CDTX, and 4 is remit. So you can see in the right picture, the 0, 1, 4 is the much more better one in this whole graph. As you can see, 0, 1, 4 is just customer info, DP, and remit. So you can see that's why our model finally just concat these 3 data in our model. So this is our whole recap. Firstly, we pre-processing all our data in dataset, and then we put data into model. And lastly, we fine-tune in 3 ways. First one is change the weight of penalty. Second one is change the layer size in dense layer. And the third one is change dataset concat in this model. So you can see our best parameters are all in gray. That is our final result. And thanks for your listening. This is our whole presentation.